According to the National Electrical Code, Article 440.6 specifies that air handling unit branch circuits must have overcurrent protection rated not greater than 125% of the air handling unit's rated load. Article 440.13 states that branch circuits for air handling units must be protected by a circuit breaker or fuse rated no larger than the rating of the circuit. The correct method to connect a heat pump air handler to an existing electrical feeder is outlined as follows. Firstly, check the load calculation. Determine the maximum load of the air handler in amps using the manufacturer's specifications or a load calculation. Secondly, size the breaker or fuse. Select a circuit breaker or fuse rated for 125% of the air handler's calculated load. Thirdly, install the breaker or fuse. Install the breaker or fuse in the main electrical panel or at the air handler if there is a dedicated breaker panel. Fourthly, run a new branch circuit. Run a new branch circuit from the main electrical panel or breaker panel to the air handler using the correct wire size for the amp rating determined in the first step. Fifthly, connect the new branch circuit. Connect the new branch circuit to the air handler's electrical terminals. It is important to note that the main panel breaker should not be changed without consulting with a qualified electrician, as this could affect the overall capacity of the electrical system. If there is no breaker at the air handler, one should be installed to provide overcurrent protection for the equipment. It is not recommended to tap into the existing feeder wire, as this can create a safety hazard and could result in code violations. Let's delve deeper into each of these steps to ensure a comprehensive understanding of the code-compliant installation process. Starting with the load calculation, accurately determining the maximum load of the air handler is crucial for selecting the appropriate overcurrent protection. The manufacturer's specifications typically provide the rated load in amps, but a manual load calculation may be necessary in certain situations, especially if the air handler has multiple components with varying power requirements. This calculation should include the fan motor, heating elements, and any other auxiliary devices connected to the air handler. Once the maximum load in amps is determined, the next step involves sizing the breaker or fuse. According to the NEC, the overcurrent protection device should be rated at 125% of the air handler's calculated load. For example, if the air handler's calculated load is 20 amps, the breaker or fuse should be rated at 25 amps. This 125% rule accounts for the intermittent nature of the air handler's operation and prevents nuisance tripping of the overcurrent protection device. After selecting the appropriate breaker or fuse, the next step is to install it in the main electrical panel or the air handler if there is a dedicated breaker panel. The location of the overcurrent protection device depends on the specific installation requirements and the availability of space in the main electrical panel. If there is sufficient space in the main panel, installing the breaker or fuse there is generally the preferred option, as it provides a central point of control and protection for the air handler circuit. However, if the main panel is already crowded or if it is more convenient to install the overcurrent protection device closer to the air handler, a dedicated breaker panel can be used. In either case, the overcurrent protection device must be properly installed and labeled to ensure safe and reliable operation. Once the overcurrent protection device is in place, the next step is to run a new branch circuit from the main electrical panel or breaker panel to the air handler. The wire size for the branch circuit must be selected based on the amp rating determined in the load calculation. The NEC provides tables that specify the ampacity of different wire sizes based on the type of insulation and the ambient temperature. It is important to consult these tables to ensure that the wire size is adequate for the intended load. In addition to the wire size, the type of wiring method used for the branch circuit must also comply with the NEC requirements. Common wiring methods for air handler circuits include non-metallic sheet cable, electrical metallic tubing, and flexible metal conduit. Each of these wiring methods has its own set of installation requirements, which must be followed to ensure safe and code-compliant installation. After the branch circuit is run to the air handler, the final step is to connect it to the air handler's electrical terminals. The air handler typically has a junction box with clearly labeled terminals for connecting the power supply wires. It is important to follow the manufacturer's instructions when connecting the branch circuit to the air handler's terminals. In addition to these 5 steps, there are a few important notes to keep in mind. Firstly, the main panel breaker should not be changed without consulting with a qualified electrician. Changing the main panel breaker can affect the overall capacity of the electrical system and could potentially overload the system, leading to a safety hazard. A qualified electrician can assess the existing electrical system and determine whether it is capable of handling the additional load of the air handler. Secondly, if there is no breaker at the air handler, one should be installed to provide overcurrent protection for the equipment. This is especially important if the air handler is located a significant distance from the main electrical panel, as it provides an additional layer of protection in case of a fault in the branch circuit. Thirdly, it is not recommended to tap into the existing feeder wire, as this can create a safety hazard and could result in code violations. Tapping into an existing feeder wire can overload the circuit and create a fire hazard. It can also violate the NEC requirements for overcurrent protection and conductor sizing. By following these steps and keeping these notes in mind, you can ensure a safe and code-compliant installation of a heat pump air handler. Remember to always consult with a qualified electrician if you have any questions or concerns about the installation process. Now, let's consider some common scenarios and address potential challenges that may arise during the installation process. One common scenario is when the existing electrical feeder is not adequately sized for the new heat pump air handler. In this case, it may be necessary to upgrade the feeder to a larger size to accommodate the increased load. This typically involves replacing the existing wire with a larger gauge wire and upgrading the overcurrent protection device in the main electrical panel. Another scenario is when the main electrical panel is already full and there is no space for an additional breaker. In this case, it may be necessary to install a subpanel to provide additional breaker capacity. A subpanel is a smaller electrical panel that is fed from the main electrical panel and provides a separate distribution point for branch circuits. When installing a subpanel, it is important to follow the NEC requirements for grounding and bonding to ensure a safe and reliable installation. Another potential challenge is when the air handler is located in a difficult-to-access area, such as an attic or crawl space. In this case, it may be necessary to use special wiring methods or techniques to run the branch circuit to the air handler. For example, flexible metal conduit may be used to navigate tight spaces or obstacles. It is also important to ensure that the wiring is properly supported and protected from physical damage. In addition to these specific scenarios, there are also some general safety precautions that should be followed during any electrical installation. Firstly, always disconnect the power to the circuit before working on any electrical components. This can be done by turning off the breaker in the main electrical panel or by removing the fuse. Secondly, use appropriate personal protective equipment, such as insulated gloves and safety glasses. Thirdly, follow the manufacturer's instructions for all electrical components and tools. Fourthly, if you are not comfortable working with electricity, hire a qualified electrician to perform the installation. Electricity can be dangerous, and it is important to take all necessary precautions to ensure your safety. Now, let's discuss the importance of proper grounding and bonding in heat pump air handler installations. Grounding and bonding are essential for providing a safe path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electrical shock. The NEC requires that all metal parts of the electrical system, including the air handler chassis, be properly grounded and bonded. This is typically accomplished by connecting a grounding conductor from the main electrical panel to the air handler's grounding terminal. The grounding conductor should be sized according to the NEC requirements and should be securely connected to both the main electrical panel and the air handler. In addition to grounding the air handler chassis, it is also important to bond any metal water pipes or gas pipes that are located near the air handler. Bonding helps to equalize the potential between these pipes and the electrical system, which reduces the risk of electrical shock. The bonding conductor should be sized according to the NEC requirements and should be securely connected to both the metal pipe and the air handler's grounding terminal. Proper grounding and bonding are essential for ensuring the safety of the electrical system and protecting people from electrical shock. It is important to follow the NEC requirements for grounding and bonding to ensure a safe and code-compliant installation. Now let's talk about the importance of proper labeling of electrical panels and circuits. Proper labeling is essential for identifying the different circuits in the electrical system and for quickly locating the correct breaker or fuse in case of a fault. The NEC requires that all electrical panels and circuits be clearly and accurately labeled. The labels should indicate the purpose of each circuit, such as air handler, lighting, or outlets. The label should be permanently affixed to the electrical panel and should be easy to read. In addition to labeling the electrical panel, it is also important to label the individual breakers or fuses. The label should indicate the circuit that each breaker or fuse protects. This will make it easier to identify the correct breaker or fuse in case of a fault. Proper labeling of electrical panels and circuits is essential for safety and convenience. It allows electricians and homeowners to quickly identify and isolate circuits for maintenance or repair. It also helps to prevent accidental disconnection of critical circuits. Now let's discuss the importance of regular maintenance of heat pump air handler electrical systems. Regular maintenance is essential for ensuring the safe and reliable operation of the electrical system. Maintenance should include visual inspections of the wiring, connections, and overcurrent protection devices. It should also include testing of the grounding and bonding system. The wiring should be inspected for any signs of damage, such as frayed insulation or loose connections. The connections should be checked to ensure that they are tight and secure. The overcurrent protection devices should be tested to ensure that they are functioning properly. The grounding and bonding system should be tested to ensure that it is providing a low impedance path for fault current. Regular maintenance can help to identify and correct potential problems before they lead to a failure or a safety hazard. It can also extend the life of the electrical system and reduce the risk of costly repairs. It is recommended that a qualified electrician perform regular maintenance on the heat pump air handler electrical system. The electrician can perform a thorough inspection of the system and identify any potential problems. The electrician can also make any necessary repairs or replacements to ensure that the system is operating safely and reliably. Now let's delve into some specific NEC code sections that are relevant to heat pump air handler installations. Firstly, NEC section 110.3 covers examination, identification, installation, and use of equipment. This section requires that electrical equipment be installed and used in accordance with the manufacturer's instructions and that it be suitable for the intended purpose. Secondly, NEC section 210.12 covers arc fault circuit interrupter protection. This section requires that certain branch circuits be protected by arc fault circuit interrupters, which are designed to detect and interrupt arc faults, which are a common cause of electrical fires. Thirdly, NEC section 250 covers grounding and bonding. This section provides detailed requirements for grounding and bonding electrical systems to ensure safety and prevent electrical shock. Fourthly, NEC section 310 covers conductors for general wiring. This section provides requirements for the ampacity, insulation, and installation of electrical conductors. Fifthly, NEC section 422 covers appliances. This section provides requirements for the installation and wiring of appliances, including heat pump air handlers. Sixthly, NEC section 430 covers motors, motor circuits, and controllers. This section provides requirements for the installation and wiring of motors, which are commonly used in heat pump air handlers. Seventhly, NEC section 440 covers air conditioning and refrigerating equipment. This section provides specific requirements for the installation and wiring of air conditioning and refrigerating equipment, including heat pump air handlers. It is important to consult these NEC code sections to ensure that the heat pump air handler installation is in compliance with the applicable codes and standards. These code sections provide detailed requirements for the installation and wiring of electrical equipment and are essential for ensuring the safety and reliability of the electrical system. Furthermore, let's discuss the different types of overcurrent protection devices that are commonly used in heat pump air handler installations. The two main types of overcurrent protection devices are circuit breakers and fuses. Circuit breakers are electromechanical devices that automatically interrupt the flow of current in a circuit when a fault occurs. Fuses are single-use devices that melt and interrupt the flow of current when a fault occurs. Circuit breakers are generally preferred over fuses because they can be reset and reused, while fuses must be replaced after they blow. There are several different types of circuit breakers, including thermal magnetic circuit breakers, electronic trip circuit breakers, and ground fault circuit interrupters. Thermal magnetic circuit breakers are the most common type of circuit breaker and are used in a wide range of applications. Electronic trip circuit breakers offer more advanced features, such as adjustable trip settings and diagnostic capabilities. Ground fault circuit interrupters are designed to protect against ground faults, which are a type of electrical fault that can cause electrical shock. The type of overcurrent protection device that is used in a heat pump air handler installation depends on the specific requirements of the installation and the preferences of the electrician. It is important to select an overcurrent protection device that is rated for the appropriate voltage, current, and interrupting capacity. The interrupting capacity of an overcurrent protection device is the maximum amount of current that the device can safely interrupt. It is important to select an overcurrent protection device with an interrupting capacity that is sufficient for the potential fault current in the circuit. Finally, let's reiterate the importance of hiring a qualified electrician for heat pump air handler installations. Electrical work can be dangerous and should only be performed by qualified individuals who have the necessary training and experience. A qualified electrician will be familiar with the NEC codes and standards and will be able to ensure that the installation is safe and code compliant. A qualified electrician will also have the necessary tools and equipment to perform the installation correctly. Hiring a qualified electrician can help to prevent electrical fires, electrical shock, and other safety hazards. It can also help to ensure that the heat pump air handler system operates efficiently and reliably. In conclusion, the installation of a heat pump air handler requires careful attention to detail and compliance with the National Electrical Code. By following the steps outlined in this narration and consulting with a qualified electrician, you can ensure a safe, reliable, and code-compliant installation. Remember to prioritize safety, use appropriate materials, and adhere to all applicable codes and regulations. A properly installed heat pump air handler will provide years of comfortable and efficient operation.